This is block 4 from topic 3. This is page 78 in your workbook. So if you aren't there yet, turn to page 78. And first thing, so I need to get to the right page. All right, these two tables should look pretty familiar to us already. We talked about them yesterday. Pizza without delivery and pizza with delivery. And without delivery, well, which one was proportional?
The one without delivery.
One without delivery. And the one with delivery, was it proportional?
Yes.
No, it did not go through the origin. Okay, so we're going to investigate one more thing here. I want to look at the quotients of these numbers. So I'm going to look at the first table. What does quotient even mean? Answer to a division problem. But we're going to leave it as fractions, and we're going to look at them as fractions. And I want to look at the cost per pizza of each of these scenarios. What is unique about all of these quotients? Jonathan?
Yeah, they all have the quotient of 7.
They all have the same quotient of 7 over 1. Do y'all agree?
Yes.
14 over 2 simplifies to 7 over 1. 21 over 3 simplifies to 7 over 1. And 28 over 4 simplified to 7 over 1. I like it. They all have this equivalent quotients. My next video here will simplify those. So you need to record this on your problem 1 table.
So just put all one.
I would put all that I have written. So they all reduce to 7 over 1.
Do you want us to write?
Yes, it all. Thanks for asking. So, would you agree that 7 over 1 consistently happened?
Yes.
Because the word constant means it repeatedly happens or occurs. So what is the constant for this pizza without delivery?
7 over 1.
7 over 1 or just 7?
7.
Okay, either one. That is its constant. And we like to call it its constant of proportionality. So since it has the same constant, it is a proportion. Hence, constant of proportionality. So this table we knew was proportional. That's why it has a constant. Looking at the next table, could we take some guesses as to if those quotients will be equivalent or constant?
No.
Okay, we're thinking no. Anybody thinking yes? Nice slide there. Looking at this table and those quotients, do they reduce to the same thing? No. So, does this have a constant? No.
So it's not proportional.
Something is not constantly happening. It does not have a constant of proportionality, so it is not proportional. So I would like you, I had this on my marker board, but I guess I won't put it on my marker board. I would like you, where those tables were, you had 2 tables. Next to those tables, for this first table column, what did we call that value?
7 over 1.
That's what it was. We called it a constant because It's proportional. So write that next to that table somewhere. It's we call that number 7/1 a constant because it is proportional.
P-R-O-P.
Sure. Well, this other table, I need a vocabulary word that kind of means the same thing as constant of proportionality, because didn't we do the same process?
Yes.
But I can't call it constant of proportionality because it's not proportional. But I did the same process. So I'm going to call that word rate of change. Did you have it? That is what I'm calling this, rate of change. Because it's not proportional. However, I could also call this a rate of change. Because it had a rate but can I call this second table, can it have a constant of proportionality? No, because it's not proportional. But both of them can have a rate of change because they're both changing over time. So both can be called rate of change, but only one, the proportional one, can be constant of proportionality. So, you got that written? Pencils down. We're going to do some serious recap here. This problem is not in your book, so we're just recapping a lot of things here. And we're diving in deep, so stay focused. Ready? Here we go. I have a table and an equation. Is this an example of proportional or non-proportional?
Proportional.
Okay, it is proportional. How does the table tell me it's proportional? Two things had to happen. What?
Because you're multiplying everything by 2, because 1 times 2 equals 2, and 7 times 2 is 1. I mean, everything you divide.
It's quotients, basically what we just did. So if I look 7/1, 14/2, stop with the tapping because it's tracking. 21/3, 28/4, all reduced to what? 7/1. Do you agree every time right here it's increasing by 7 on the y's? The x's is increasing every time by 1. Okay? This is where the advanced students stay advanced and the others do not. Is staying focused right here. Because I'm going to tell you, some high schoolers still can't tell me this because they don't pay attention right now. And you use this in 8th grade, you use it in 9th grade, 10th grade, 8th grade, and through college. So, stick with me. I missed it. Yeah, I know.
11.
So, the fact that it was increasing by the same amount, that tells me the line is going to be straight. What tells me it's going to go through the origin? Grady.
It starts at 0 and this starts at 0?
The 0, 0 start tells me it's going through the origin. So the table I know is proportional because it goes through the origin and it has a constant of proportionality is the same, or the rate of change is the same throughout all the x or y over x quotients. What in the equation tells me it's proportional? Well, some of us may have forgotten this by now. We've written a sticky note that said a constant of proportionality equation is in the form of y equals kx. Is there any plus signs or minus signs in this form? So looking back at this equation, how do I know it's going to be a proportional equation? Is it in that form?
Yes.
That's how I know it's a proportional equation. All right. When I look at its graph, how do I know it's proportional?
Because it touches the line. It's a straight line and touches the line.
Because it's a straight line and it goes through the origin. So I know it is proportional. Now let's go. What is this an example of? Non-proportional. What in the table immediately tells you it's not proportional?
It doesn't start and it has 0 for the first.
It doesn't have a 0, 0. It has a 0, 5. So is it going through the origin? No. But looking at it, I could tell it's a straight line. Because from 5 to 12, how much did I increase? 12 to 19. 19 to 26. It's increasing by 7, and this x's are increasing by 1. So I know it's a straight line, but it had to meet both those criteria. So it was a straight line, but is it going through the origin? No.
Oh, and there's also addition in the.
We haven't gotten there yet. So in the equation, what immediately tells me that it's not an example of a proportional equation?
There's addition in the equation for.
There is addition.
Wait, so
This is a proportional equation form. It doesn't have any addition. Yes, sir.
Is that proportional? Proportional, it doesn't have like a plus or minus sign,
Correct.
but non-proportional does.
Correct. So, looking at the graph of this, what immediately tells me it is non-proportional. Because it's not going through the origin, but it was straight. Doesn't matter. It had to meet both rules, straight and through the origin. So if I looked at both of these together, at first glance, they kind of look the same. There's little differences. Like in the graph, what's the little difference? The origin is going through on proportional, non-proportional, it's not going through. What's the little difference in the equation? The plus 5.
And one's blue and one's red.
So I could, what if I said y equals 2x plus 6? Proportional or non-proportional?
Non-proportional.
Non-proportional, because it had what?
A plus.
Plus 6.
Yep.
Is that proportional or non-proportional?
Proportional.
Proportional. What if I had a table? Proportional. Check this out.
Non-proportional.
What is making this non-proportional? What?
When you go from 2 to 5, it increases by 3 instead of 2.
Here I increase by 2. Here I increase by 3, 2. But each of these was a 1.
So it's not.
Did it increase consistently?
Yes.
Not on both sides.
Not on both sides. Is this table an example of a proportional table?
No, it's an example.
It would go through the origin, but is it going to be a straight line? No. I could immediately say that that is non-proportional.
Why is
So-
wait, why is it not proportional?
Why is it non-proportional?
Oh.
It's not through origin. If it starts at 0, it better say another 0, or it's not proportional.
What does it start with? Okay, never mind, because it can still go to.
Because if it's 0, 6, then it just goes up.
Yeah. You just answered 9th grade Algebra 1 EOC questions
Let's go.
that some high schoolers still have trouble with. That is good. Like I said, some people still struggle with this in high school. You're using it the rest of your math career. Okay, so that was our grand recap. We have one more question. And this is question 2 in your book, using that same information.
What about AB?
Question 2. Oh, question 1 and let's go to question
We did those.
1. We already really answered question 1A, but 1A says complete the table for the pizzas with delivery. Underline with. So with delivery, which table am I looking at? The second one.
The second one.
So it says, what do you notice about those quotients? So what do I notice about those quotients?
They are unproportional.
They're unproportional.
They add up by 7.
John said it's adding 5.
I notice, are they equivalent?
No.
I would say not equivalent. You didn't right off the bat look at it and say, oh, it's not proportional because I'm super smart.
Wait, should we write that for number 1?
1A, not proportional. And we underlined the word with because we were looking at the second one.
Not equally.
Wait, we put not equivalent or not proportional?
Not equivalent. 1B states without. So I'm going to underline that. That means I'm looking at the first table, and it asks what I notice about the quotients. What do I notice about those? They're equivalent.
That means not proportional.
It also, if those particular quotients was not equivalent, then it was not proportional. But just for that particular problem. All right, now we're ready for problem 2. And it looks like my recording is cutting out, so there we go. So, it says, each of these graphs represent a line, which means that they grow at a constant rate. We agreed each of them is going up by 7 every time.
Yes, ma'am.
Thank you. It's going up by 7 every time. So we're calling that rate of change. So what is the rate of change of this red line?
7.
What is the rate of change of the blue line?
7.
They both were 7. But I can get more specific and call the red line's rate of change. I can also call it what? Constant of proportionality. Can I call the blue line a constant of proportionality?
No.
Because it is not proportional. So it says, what is the rate of change for these graphs? $7. The rate of change for both was $7. That was 2A. Then it says, for the proportional situation, the rate of change is also the constant of proportionality. So that just recaps what I said. This proportional one can also have a constant of proportionality. So your 2b says for the proportional situation, how can you identify the constant of proportionality?
By dividing.
How did you find the constant of proportionality? What did you immediately look at?
1.
The equation, or you could have looked at the 1, but can you really tell from the graph where it exactly is falling?
Yes.
No.
Well, you're a genius. But I look at the equation, and what part of the equation tells me it's constant of proportionality?
Number.
What is that number called, where it's sitting? The coefficient. So 2b is the coefficient. C-O-E. C-O-E-F-F-I-C-E-N-T. It's a
I think you're trying to spell
Okay. Lastly, we have a sticky note recap. Look at all the noise it's tracking. Thank you.
People keep writing this.
Does it matter where we put it?
No. We're going to title this Rate of Change. And we have established rate of change means the same as unit rate. Or sometimes it can mean the same as constant of proportionality only if the problem is proportional. So we're going to put this in topic 3, block 4, anywhere in that section. When you're done writing this, problems 3 through 5 will be homework, and I will be checking those tomorrow. Thanks for listening. Like, subscribe, and hit the notification bell.
Yeah.